What if I told you that some of the greatest advancements in space exploration came from failures? It's a bold claim, isn't it? But in the grand scheme of space exploration, it holds a profound truth. We, humans, have always been fascinated by the mysteries of the cosmos, propelling us to reach for the stars. This journey, however, is not without its fair share of trials and tribulations, and sometimes these trials culminate in what we perceive as failures. But in the realm of scientific discovery, failure isn't the end. Instead, it's a stepping stone, a catalyst for progress, a source of invaluable lessons. It's through these failures that we've been able to turn the impossible into possible, to learn, adapt, and advance. A failed space mission might seem like a setback, but it's often a launchpad for groundbreaking advancements. So let's dive into the top 5 failed space missions and the valuable lessons we've gleaned from each. First on our list is the Mars Climate Orbiter, a mission that went awry due to a simple unit conversion error. The Mars Climate Orbiter was a robotic space probe launched by NASA in 1999 with the purpose of studying the Martian climate, atmosphere, surface changes, and to act as a relay station for the Mars Polar Lander. But it never got to fulfill its purpose. A small oversight turned fatal when the team behind the mission failed to convert English units to metric units. This seemingly minute error caused the orbiter to approach Mars at a lower altitude than intended, leading to its disintegration in the Martian atmosphere. The Mars Climate Orbiter's unfortunate demise underscored a critical lesson: the absolute necessity for standardization and thorough checks in scientific missions. A simple unit conversion error cost millions of dollars and years of work, reminding us that in the realm of space exploration, there's no room for even the smallest of mistakes. This mission underscores the importance of meticulous attention to detail in space exploration. Next up is Beagle 2, a mission that reminds us of the unpredictable nature of space. Launched in 2003, Beagle 2 was a British-led space mission to Mars, with the objective of searching for signs of life on the Red Planet. It was a mission filled with hope and promise. But as it descended onto the Martian surface, communication with Beagle 2 was abruptly lost. The mission was declared a failure. The culprit? Unexpected atmospheric conditions on Mars, which the spacecraft wasn't designed to withstand. Yet from this failure emerged a valuable lesson. It underscored the need for contingency plans in space missions. It taught us that adaptability is key when venturing into the unknown, because as we've seen, space can be as unpredictable as it is vast. Beagle 2 shows us that space is full of surprises, and we must always be prepared for the unexpected. Third on our list is Genesis, a mission that failed but still managed to provide valuable information. The Genesis spacecraft was launched in 2004 with an ambitious goal: to capture solar wind particles and bring them back to Earth for analysis. However, the mission met an unfortunate end when its parachute failed to deploy during re-entry, resulting in a crash landing. The unexpected downfall of Genesis was primarily attributed to a design flaw in the parachute deployment system. This failure underscored the vital importance of redundancy and backup systems in space missions. It's a stark reminder that space is unforgiving and a single point of failure can jeopardize an entire mission. Yet even in its failure, Genesis was not a total loss. The crash landing was a blow, yes, but scientists were still able to retrieve and analyze some of the samples. Genesis teaches us that even in failure, there's always something to be learned. Fourth, we have the Phobos-Grunt, a mission that reminds us of the importance of robust communication systems. Launched by Russia in November 2011, this ambitious mission aimed to bring back samples from Phobos, one of Mars's moons. It was a daring venture, pushing the boundaries of what we thought possible. However, things didn't go as planned. After the spacecraft reached Earth's orbit, a crucial engine burn needed to set it on its way to Mars failed. The reason? The spacecraft lost communication with the mission control. Without this vital link, the Phobos-Grunt was left stranded in Earth's orbit, eventually re-entering the atmosphere and disintegrating. This unfortunate incident served as a stark reminder of the critical role that effective communication systems play in space missions. When venturing into the vast unknown, maintaining a reliable line of communication is not just a convenience, it's a necessity. Phobos-Grunt underscores the importance of communication in successful space exploration. Last but not least, we have the Schiaparelli EDM Lander, a mission that failed due to a simple software glitch. The Schiaparelli EDM Lander, a joint venture of the European Space Agency and Roscosmos, was designed to test technologies for landing on the Martian surface. Its primary purpose was to pave the way for future Mars exploration missions. However, the mission didn't go as planned. A mere 50 seconds before the scheduled landing, the onboard computer misinterpreted the data, causing the lander to freefall the final 3.7 kilometers onto the Martian surface. This software glitch, as simple as it was, led to the lander's demise. The failure of the Schiaparelli mission underscored the critical importance of reliable software in space missions. It highlighted the fact that even with the most advanced hardware, a small software error can derail an entire mission. Schiaparelli reminds us that even the smallest of errors can have large consequences in the vastness of space. So, what do all these failed missions tell us about space exploration? Well, they reiterate the fact that failure, as harsh as it may seem, is an essential part of progress. Every mishap, every miscalculation, every malfunction, they all serve as stepping stones towards advancement. Take the Mars Climate Orbiter, for instance. Its failure highlighted the importance of a universal metric system in international collaborations. The Beagle 2, despite not fulfilling its primary mission, taught us the significance of contingency plans. The Genesis, with its crash landing, underscored the need for meticulous testing. The Phobos-Grunt, it reminded us of the complexities of space travel, pushing us to innovate and improve. And the Schiaparelli? Its unfortunate demise amplified the need for rigorous pre-launch simulations. Each failure, each setback, has led to improved techniques, better technology, and more successful future missions. It's a cycle of trial and error, of daring and learning, of falling and rising. In the realm of space exploration, it is not just the successes, but also the failures that propel us forward into the unknown.